write the parameters from the beginning. So what are the parameters? Let someone read the question.
The bus has a volume of...
So the volume of the bus, I'll use V for the volume of the bus, equals what?
0.28
meters cube.
And 70% filled with iron filing at 25 degrees C.
Okay, so the initial temperature of the the bus and the filing is, I used theta 1, is how many degrees?
25 degrees C.
25 degrees centigrade.
Calculate the total mass of the iron filing.
We should calculate the total percentage of the total mass of the what? Iron filing. And the iron filing is filled with 70% of, also the bus is filled with 70% of iron filing. Is that not? So we're going to get the volume of iron filing. Volume of iron filing. It's going to be 70%. That's 70 divided by 100. The volume of the bus, is that not? Yes. Times 0.28 meters cubed. So let's work this out. This is going to give us, if we work that out. So that gives us what? 0.196 meters cubed, right? That's the volume of the iron filings inside the what? Bus. Do you understand what I'm doing?
Yes, sir.
Okay. Now the next thing we have to do is they say we should look at the mass, the total mass of the iron filings inside the what? Bus. Now we know that density is equal to mass divided by what? Volume. So from this, the mass is going to be equal to what? Density times volume. It's not divided now. Times volume, isn't it? So here I'm going to multiply this now. So the mass of the iron filing is going to go to what's the density of iron filing?
8 times 10 is
8.00 times 10 power what?
3
what? Kilogram per meter so times, so the volume we calculated is what? 196 meters. So let's work that out. That's going to give us what? 1,568 kilograms. So that is the total mass of the iron filings. Are we good?
Yes, sir.
So next, we have to find the energy that is required to melt 10% of the what? Iron. So the mass of the iron filing is 1,568 kilograms. Is that not? So 10% of this is 10 over 100 times 1,568 kilograms, right? So the mass that is going to be used, that is going to melt is 10%. That's 10 over 100 times 1,568. So that will give us what? That's going to give us what? 156.8 kilograms. So this is the mass that is going to what? Melt. Now, there's something you need to understand here now in this question. Okay, now this is the mass that is going to what? Melt. Now, when heat is supplied to an object at a particular temperature, the temperature rises until it gets to its melting point. So by that time, the heat that is supplied, or the energy that is supplied to that body, is required to raise the temperature to the melting point of that what? Object. What I mean is that, you know, the iron filings was at, the initial temperature of the iron filing was what? 25 degrees centigrade, isn't it? And the melting point of iron filing is what? 1,500 degrees centigrade, isn't it?
Oh, yes.
So that is the melting point for the ice. So from 25 degrees to 1,500 degrees centigrade, the heat supplied to it is going to raise the temperature from 25 degrees to what? 1,500 degrees. So that heat is going to be obtained due to the specific heat capacity of what? The object. It means that the heat is going to be equal to, you can use symbol H for heat or Q, is that not?
Yes.
So the heat required, okay, let me write it, heat required to raise the temperature of the ion filings from 25 degrees centigrade to 1500 degrees centigrade is, so I'll use this, H equals the mass M times the specific heat capacity times the temperature what?
Right.
Change. I said you can use Q or what? H. It doesn't mean H. Quantity of heat supply. MC delta what? Theta. H equals MC delta theta. Heat. Quantity of heat supply. You can use any of them. I will follow it. So this is the quantity of heat required to what? Raise the temperature from what? 25 degrees to what? 1000 what? 5. What's your question?
The iron filling, is it gaining heat?
Yes, it's going to gain heat. Why? Why is it going to gain heat? Because it was at a lower temperature, the 5 degrees centigrade, and the temperature now rises to what? 1500. Is that now?
Yes.
So it's gaining heat. So this is going to give us. Now I'm going to call this H1 because we are going to calculate the heat that is required to melt the ice at each melting what? Point. So H1
H.
is equal to. So what's M now? What's the mass? 156.8 times what's the specific capacity of the 460 degrees joules per kilogram per Kelvin times the temperature change is what? 1500, the final temperature minus the initial what? Temperature, degrees centigrade. These are very simple. Just apply the formula. So let's work this out. So I'm going to have 156.8 times 460 times. Subtract this for me quickly. 1475, isn't it?
Yes.
So multiply all of this together for me. Read the digit. Read the digit to 2 decimal place and write it 10 in standard form quickly. Yes.
1.0
To 2 decimal places.
1.06
1.06 times 10 to the power what? 6 times 10 to the power 6 joules. So this is the heat that is required to raise it from 25 degrees to what? 1500. The heat, you can see that it is very high. Why is it very high? Because the temperature difference is very what? High. To raise 25 degrees, a substance from 25 degrees to 1500 degrees centigrade requires. It's paused. Now we have obtained the heat energy required to raise the temperature from 25 degrees centigrade to 1500 degrees centigrade. Now the next thing we have to look at is that because we are looking at the total heat that is required to what? Melt this mass of the iron, is that not? Right? So this is going to give us, now this is going to be, the heat required to melt the ice is the heat required to change it from a solid state to a liquid state without any temperature what? Rise. So that is going to be the heat supplied to the body due to the what? Latent what? Heat. So it therefore means that I'll call this H2 equals, okay, let me write this in what? Heat required to melt the iron filings at 1500 degrees centigrade. That's the melting point, is that not? The melting point is, so I'm going to use H2 equals the mass times what? Latent heat. So what mass are we melting? 156.8, is that not? So that would give us H2 equals 1 156.8 times, what is the latent heat?
1.3.
Specific latent heat is what? 1.38
times 10
times 10 to the power what?
5.
5 joules per what? Kilogram, right?
Yes.
So let's multiply this and leave the answer in standard form, please. So multiply this. Nathaniel, multiply for us. 156.8
and 1.3
times 1.38 exponential 5.
that's 2.16
Did you pause it? 2 point.
times 10 raised to the power 5.
5 joules. Are we seeing that now? So now the total heat that is required to melt all of this is going to be the heat that is required to raise the temperature to its melting point plus the heat required to what? Melt it. Is there a problem with this?
No.
Tell me now, what's the problem?
When you are changing it to time, look at the answer here. So how many is it? The camera is
1, 2, 3, 4, 5, 6, 7.
okay, 7. That means 28. 28.
Okay, this one is 8.
And that one is
And this one is what?
7.
7. So we have corrected that.
Yes.
So 2.16 times 0.7 joules. So the heat, the total heat that is required to melt it is the heat that raises the temperature from what? 25 degrees to what? 1005, which is the melting point, plus the heat required to change the what? State from solid to what? Liquid. So that is going to give us, that's H1 plus what? H2. So H is equal to, so H1 is what? 1.06 times 10 raised to the power 8 plus 2.16 times 10 raised to the power 7. So we add all of them together, they are in joules, Abi.
Yes.
So that gives us what? Let's add this together. 3.22
Times 10 is what?
times 10, no. Let's add it, add. 1.06, this is what you normally do. Press 1.06 from your calculator exponential 8 plus 2.16 exponential 7. Add it together that way. Add it that way. 1.27 times 10 raised to the power 8 joules. So this is the total heat that is required to what? Melt the what? The whole of the what? Iron. That is 156.8 mass of what? The iron. Is there any question? Okay, what's your question?
Required to make 10% of the iron.
So we calculated 10% of the iron to be this. The mass of the iron that we got. What was the mass of the iron that we got? We got 1,568 joules. So 10% of this is what? 156. 10% of this is 10 divided by 1. That's 0.1 times base. That gives us what? 156.8. We calculated that. So what other question again? Okay.
In the question,
Okay.
this mass that you calculated,
Yes.
how much will this mass be said when you are calculating for the full iron filling?
Okay. In the question, they started the question by saying that a bus has a volume of what? 0.28 meters cubed, is that not? And the bus was 70% filled with what? With iron filings, is that not? So the volume of the iron filings, is 70% of the volume of what? The bus. Let me illustrate with this. Let's assume I have a bus. Please, let's look at this. Let's assume I have a bus like this. The volume of this bus is 0.28 meters cubed. And I have iron filings filling this bus to a certain level, which is what? 70%. So let's see. Let's assume this is the 70%. The iron filing is filling. Okay, now let's see. So this is 70% of this, right? So if this is 70% of this, the volume of the ion filing is going to be what? The 70% of the total volume of what? The pore, that's 0.28, right? That is 70 divided by 100 times 0.2. That's how we arrive at the volume of what? The ion filings, isn't it? So we arrived at what was the volume of ion filings that we arrived at? That was 0.196 meters cubed, right? So we arrived at that, isn't it? Now, the total mass of ion filings inside this pore, because we are given the density of ion filings now, you know that mass is equal to what? Density times what? Volumicity.
Yes.
So we use this to calculate what? The total mass that occupies 70 what? Percent, isn't it? Are we following?
Yes.
It was 70% that was here. So the total mass of 70% inside this box was calculated as N equals the density. What was the density of iron? 8.00 times 10 raised to power what? 3 times the volume is what? 0.196. So when we arrived at, we now arrived at what? 1568 kilogram, right? But then after that, we should calculate the total heat that will be required to what? Melt 10% of this. 10% of this is 10 over 100 times 1568. Abi, which is 10% is 0.1 times 1568. So when we multiply that, this will give us 156 point what? 156.8 kilograms. So this is what we are required to what? Melt. So the heat supplied to this, because the box was initially at what? 25 degrees what? Centigrade, is that not? So heat is going to be supplied to this, which is going to raise this 25 degrees centigrade to what? The melting what? Point. And the melting point is what? 1500 what? Degrees centigrade, isn't it? So after that, we calculated that heat that raised the temperature from 25 degrees centigrade to what? 1500 degrees what? Centigrade. Then we now have to calculate the heat that is required to melt the ion filings without changing the what? Temperature. Okay, what's the question again?
They say that 10%.
Okay.
But in this, the question, the third one I saw, it said I have to melt 100 the full iron filling.
No, it's just 10% of it that will melt. So that's why we calculated 10% of it. It is not all these ion filings. We have to calculate the heat that will melt only 10% of this. That's why we use 10% of this one, 156.8. So that 156.8, the heat that is supplied to it, are we following? The heat that is supplied to this, we first of all raise the temperature from 25 degrees to what? The melting point. Then after that, it will not, the remaining heat will now convert it to what? Liquid. You get that? Any other question? There's no question. Okay. So let's